Welcome back, reinforcement learning. This session I explained navigating with Q learning, Q learning and tackling grid world. Okay, navigating with the Q learning with the example of the grid world game. Q learning I introduced in the last session. The Q function is the important for the Q learning. The Q learning is a model free reinforcement algorithm. It is learn the using Q function, based on the Q function, optimal Q function. Optimal Q function means the best reward action state action pairs. Best reward state action pairs. The actions are taken by the agent based on the environment state. Okay, which action give the best reward? Based on the state action pairs, the Q learning learn the acquire the knowledge to solve the problems. It is mainly focused on action value or Q function. The Q learning is mainly focused on action value function or Q function. The Q function maps the state value state action pairs with rewards, the predicted rewards. Here we are using in the Q learning, we are using updated Q function, updated Q value. It is estimate the more rewards. The rewards are observed from different action state pairs in during the training process. The Q learning is mainly focused on action value function or Q function. It is a mapping function from the state action pairs with predicted rewards. In this Q learning, the key concepts is state, action, Q value and updated rule. The state is the available information about the current information of the environment. Action, available options are to the agent to apply on environment, that is the action. The Q value is state action pairs mapping with rewards. The next new thing is update rule. The update rule is important in the Q learning. Here the update rule, we are calculate the update rule based on the difference between predicted rewards and observed rewards. We calculate the updated Q value using the formula. Here updated Q value of the state at the time t, action A at the time t, the Q of ST80, this is the updated Q value of the current state ST, is equal to the current Q value of the state Q ST comma AT. This is the current Q value plus here alpha is a learning rate or step size into reward, observed reward at the time t plus 1, observed reward plus gamma. Gamma is the important here, discount factor. It is the discount of the future rewards. Gamma is the plus into maximum of QST plus 1 A. It is the maximum Q value for all actions at the state ST plus 1 minus current Q value QST comma 80. This is the updated Q learning updated rule. Update Q value is equal to current Q value plus learning rate or step size into observed reward plus discount factor into maximum Q value for all actions minus current Q value. Okay, this is the formula for the Q learning update rule. Okay, the pseudocode for this one is here the parameters old Q value, reward, state, step size or learning rate and discount factor. Step size is the alpha, discount factor is gamma. Okay, here we calculate this formula. First one is the reward plus gamma into maximum of Q value for all actions of the next state. Here term 2 is equal to reward plus discount factor into maximum of the Q state action for all actions in the state. Next one is this is after this we are subtracted from current Q value. So this is term 2 minus old Q value. The next one is this total is multiplied with the step size. So this step size into term 2. The finally that this one is added to current Q value. So next return old Q value plus term 2. This is the pseudo code for the updated rule of the Q learning. Okay, this is called the Q learning updated rule. Q value at a time is updated to be the current predicted Q value plus the amount of value we expect in the future. Okay, that is updated Q value. Here the key concept in Q learning, we update the Q value based on the exploration and exploitations. The exploration means choosing actions at random to discover the new states. The exploitation is choosing the action with the highest known Q value. Okay, these exploration and exploitation tasks, the Q learning get the optimal Q functions. Optimal Q functions by this is the root of this optimal Q function is rewards. Okay, these rewards are received from the environments after applying actions. So here we are observe the Q learning with the example of the grid world. In this grid world is a classic example for to demonstrate the Q learning. Okay, it is in this problem the agent must navigate the grid. It is the 4x4 grid example is here to reach the goal while avoiding the obstacles and minimizing negative rewards. This environment is typically discrete, meaning actions are taken in a step-by-step manner and the game progresses on one turn at a time. Okay, here in this simple grid world game, the capital A indicates the agent. This must navigate the shortest path to reach the goal. The goal is indicated with the plus. Avoid the falling into the pits, minus symbols and walls W. Okay, this is the simple grid world game setup. Here the steps in taking grid world with the Q learning, the initially the Q values of the all state action pairs with must be zeros. Initially all state action pairs are given a Q value of 0. So means the agent does not have any knowledge on the game. So the agent does not know which actions will lead to reward or penalties. So initially the agent does not know any predicted rewards. So we are initialize the Q values for of the each every state action phase must be 0. Next one, start the game. In this start the game, the agent choose the actions randomly. The agent starts in random state within the grid and task is to reach the goal. In this process, the agent observe the surroundings, means the agent observe the current state ST and select the action at the time T, that is the AT. These are either based on the past experience or randomly. It is the second cycle, you choose the action either experience or exploration, or randomly, that is the exploration. So next one, after applying the actions, agent must be update the Q value for the state action pairs. After taking an action, the agent observe the new state, that is ST plus 1 and receive the reward RT plus 1. The Q value for the state action pair is updated using the updated formula. This process is continue to get the best optimal policy to maximize the future rewards. So initially we are initialize the Q values must be 0 and start the game either with exploration or exploitation with and update the Q value for after applying the every action, and this process is continue until we get the best optimal policy. Here game, this grid world game, we get the positive rewards and negative rewards. This is the training with the goal of positive rewards we are gain reaching the goal, and negative rewards are given for hitting the obstacles or wasting moves in this game. The agent started at the state ST. Yeah, what are the actions are available? Either move up, down, or left or right. So the based on the these actions, agent choose any action depend on the state. Based on the reward and the new state, it update the Q value after applying the actions. So here in Q learning, the Q function receive the input state and action. The Q function could be any function that accepts the state of the environment and action and returns the value, that is the expected reward, that is the action value, the q value return the action value, that is the expected reward by taking that action given that state. So this is the q function receive the input, the state of the environment and action, and it gives the expected reward, that is the action value. Here in this grid world example we have the two steps, step 1 and step 2. Here the grid world environment is also step 1 grid world environment. In this first step we have taken this environment, the agent move upward, the action is up, the target is plus. Here the q function receive the input, the state of this environment, and action is up. See here the q learning with the grid world, the q function accept the state and action and return the predicted reward. This predicted reward value of that state action pair. This is the reward, predicted reward is the value of that state action pair, and this is the action. We observe the reward, and after taking the action we observe the reward, and using the updated formula we use this observation to update the q learning. Here the q function receive the observed reward. So here what we get the reward, here previous without any we got the +1 or -1 or without any rewards. So here there is no it is not a target place, so it is not obstacles, so we have got the 0 only. So observed reward for this next state is 0. The q function receive the updated rule and it predict the q value is 0.5. Here second step 2 in grid world example, the agent is taking their action is right side move. So in the right side we have the target. So what the observed reward is +1. So the q function receives the state of this grid world environment and action is right. So it predict the q value, this p value is updated by using the observed reward of the next state. The next state observed reward is +1, we are reaching the target. Those q function predicted q value is 0.2. So here we are observe in the q learning, the learning process is updated in every state with the q function. With the q functions we update the q learning is updated the every state action pair q values by using updated rule to get the knowledge. It repeated the cycles to get the best optimal solution to reach the target place. So this is the grid world example is the best example to demonstrate the q learning process. Thank you.